Good morning, students. So in the last class we were discussing about some salts, important salts. So in the last class we were discussing about washing soda, and in that washing soda we know what is the formula of washing soda. Washing soda is sodium carbonate decahydrate. So this decahydrate, what is that? So that is called hydrated salts. So let us see what are hydrated salts. So next is what is hydrated salt? So hydrated salts means those water molecules, they have a fixed number of those salts, they have fixed number of water molecules in their crystalline structure, that is called hydrated salts. So this is also called water molecules of crystallization. These are also called water molecules of crystallization. So hydrated salts, those salts which have fixed number of water molecules in their crystalline structure, that is called hydrated salts. These are also called water molecules of crystallization. We know in this case, for example, decahydrate, that is sodium carbonate decahydrate, that is Na2CO3 10H2O. So this is sodium carbonate decahydrate. Another example, CuSO4 5H2O. So here 5 molecules of water of crystallization. This is called copper sulfate, pentahydrate. Penta means 5, pentahydrate. Then gypsum, that is CaSO4, calcium sulfate 2H2O, that is calcium sulfate dihydrate. So these are some of the examples for hydrated salt. So hydrated salt means those salts which have a fixed number of water molecules in their crystalline structure, and these water molecules cannot wet the salt. It cannot wet the salt, and every hydrated salts, they have a fixed number of water molecules in it. That's why I told you in example, this is sodium carbonate decahydrate. If there is no water molecule, see this is, what is the name of this compound? This is washing soda. This is called washing soda. And if there is no water molecules, that is Na2CO3, this is called sodium carbonate. So without water molecule, that is called anhydrous sodium carbonate, and that is called soda ash. That is soda ash. This is anhydrous. There is no water molecules. Anhydrous sodium carbonate. This is soda ash. But when there is water molecule, it is different. So this is called hydrated salt, and these water molecules are otherwise known as water molecules of crystallization. Now, what is the speciality of this hydrated salt, these water molecules? These water molecules impart color to that particular salt. These water molecules give color to that particular salts. For example, take an example. Copper sulfate, we know what is the color of copper sulfate. Copper sulfate is CuSO4 5H2O. What is the color of copper sulfate? We know it is blue in color. and the blue color of copper sulfate is due to the presence of this hydrated salt. If there is no hydrated salt, it will not show blue color. For example, if we are heating copper sulfate solution, when we are heating copper sulfate solution, it loses its water molecule. So, when it loses its water molecule, then it disappears the blue color. It disappears the blue color. Why? That is due to the presence of that is due to the loss of water molecule. When we are heating on dry heating, then it produces copper sulfate plus, so it loses all its water molecules. So, this is blue in color, but this is what it is a faint white color, or that is it become colorless. This is colorless or dull color or dull appearance, dull white color. And when this colorless copper sulfate solution, salt, when this colorless copper sulfate on exposed to air, then what happens, that is this colorless copper sulfate salt when exposed to air, so it readily catches, it absorbs moisture, it absorbs water molecules from the atmosphere, and then it regains its color, blue color. So, these hydrated salts impart color to that particular salts. So, this is called hydrated salts. Examples for hydrated salt: sodium carbonate decahydrate, and then copper sulfate pentahydrate, then calcium sulfate dihydrate, that is gypsum, etc. These are some of the examples for hydrated salts. So, hydrated salts are those salts which are those salts in which water molecules, there is a fixed amount of water molecules in their crystalline structure, and that impart color to that particular crystals. Okay. And these water molecules are otherwise known as water molecules of crystallization, and which cannot, these water molecules cannot wet the salt, So, that is about hydrated salt. And then I hope you understood what is hydrated salt. Then we move on to the next salt, that is the last salt, the last portion of this chapter, that is plaster of Paris. Plaster of Paris, its chemical formula is calcium sulfate half H2O, CaSO4 half H2O. It means 1 formula unit of calcium sulfate, 2 formula units of calcium sulfate shares 1 molecule of water. 2 formula units, if it is 2 CaSO4, then again there will be half H2O. So, 2 calcium sulfate molecule shares 1, half plus half 1. It means here in plaster of Paris, 1 calcium sulfate molecule shares half H2O. So, this name is calcium sulfate, its chemical name is calcium sulfate hemihydrate. This is also a hydrated salt, but here half H2O, hemihydrate, calcium sulfate hemihydrate, that is what plaster of Paris. Now, let us see how can we prepare this plaster of Paris. It can be prepared by controlled heating of gypsum. It can be prepared by the controlled heating of gypsum at 373 Kelvin. What is gypsum? Just before I told you, gypsum is what? CaSO4, calcium sulfate dihydrate to H2O. This is called gypsum. Gypsum on controlled heating at 373 Kelvin or 100 degree Celsius. So, when gypsum on controlled heating, we get CaSO4 half H2O plus H2O. This is called plaster of Paris, POP, that is plaster of Paris. Calcium sulfate dihydrate, that is gypsum on controlled heating at 373 Kelvin or 100 degrees Celsius, we get plaster of Paris. So, this is the method of preparation of what? Plaster of Paris, and this plaster of Paris is highly sensitive to atmosphere and moisture. In the when we expose to atmosphere, this plaster of Paris, they readily absorbs moisture from the surrounding, and they become what? They become a hard body and which cannot be remolded. It becomes set. That is they undergo setting. So, that is it is highly sensitive to absorb to moisture or in the atmosphere. So, it should be packed tightly, airtight packing is needed, otherwise it absorbs moisture from the air, and then it converts into a tight substance or a settled substance, which cannot be remolded, and this calcium sulfate, here we are telling in the preparation of plaster of Paris, there should be a controlled heating, but when the temperature exceeds or when it go beyond 373 Kelvin, then what is happening? That is CaSO4 to H2O, which on heating, that is without any controlled heating, or when it greater than 373 Kelvin, when the temperature is greater than 373 Kelvin, what happens? All the water molecules of gypsum lost, and then it forms a what? It is a dry burned a solid mass. We get a dry burned solid mass. So, this is burned plaster, dry burned plaster, we get dry burned plaster and plus H2O. So, we will not get, but and this dry burned plaster is no use at all, because it become what it is a tough substance, and which we cannot use this substance for any other purposes. So, that is why gypsum should be heated in a controlled temperature, that is at 373 Kelvin. When the temperature exceeds 373 Kelvin, then it converts into a dry burned plaster. That is why gypsum, for the preparation of plaster of Paris, we have to heat the gypsum in a controlled manner, otherwise we will not get plaster of Paris. Why? Because all the water molecules will be lost. Now, so this is about plaster of Paris, and we know the use of plaster of Paris. What are the use of plaster of Paris? What are the most common use of plaster of Paris? You know, where we are using this plaster of Paris. Plaster of Paris is used in the fractured, for setting the fractured bonds, isn't it? For setting the fractured bonds. It is used for setting fractured bonds. We are using plaster of Paris. Then another use, it is also used for casting statues. For casting statues, because once they combines with the water molecule, they become set. Setting will be there. So that it converts into a solid mass, which is very tight. So that's why it is used for casting statues, and then it is used in cement too. It is used in cement to delay the setting of cement, setting time. To delay its so it is used in cement to delay its setting time. Plaster of Paris is used in cement to delay its setting time. Then it is also used for dental designing. It is also used for used in dental designing. Then it is also used for in the decoration, for decorating the decoration of it is used in the decoration of ceilings and walls. So there are many uses. It is used for setting fractured bonds. It is used for casting statues, used in cement to delay its setting time. Then dental designing. Then it is used in the decoration of ceilings and walls. So these are some of the uses of plaster of Paris. So that is plaster of Paris. What is plaster of Paris? Plaster of Paris is calcium sulfate hemihydrate. That is chemical name of plaster of Paris, calcium sulfate hemihydrate. It is prepared by the controlled heating of gypsum. Gypsum, what is gypsum? Calcium sulfate dihydrate. On controlled heating at 373 Kelvin, we get calcium sulfate hemihydrate. That is plaster of Paris. And this plaster of Paris is highly sensitive to the moisture. That is why it should be packed in airtight container, otherwise it captures or it absorbs moisture, and then they convert into what? A dry mass which cannot be remolded, and then when the temperature exceeds when we are heating gypsum at more than 373 Kelvin, then it converts into a dry burned plaster which do not have any type of setting property. So that's why it should be controlled heating should be done, or in order to prepare plaster of Paris, we have to heat in a controlled temperature, that is 373 Kelvin. Then what are the use of this plaster of Paris? It is used in setting of fractured bonds. It is used in casting statues. It is used in cement to delay its setting time. Then it is used in dental designing. Then in the decoration of ceilings and walls, etc. These are some of the uses of, and then they are also used in making dustless chalk. No, this is a dustless chalk. This is also used in making dustless chalk. Also used in making dustless chalk. So these are the use of plaster of Paris. So with this we have finished the second chapter. I hope you understood all these the different salts. In this only few salts we are discussing, and with this we have finished the second chapter. Okay, so in the next class we will discuss some of the questions of this chapter. Okay, hope you understood. Wish you all a nice day. Have a nice day. Thank you.